Okay, so I'm going to call the first part of it 1213, the kind of the pre-skills that you need to be successful. So really the most important thing in this unit is being able to identify and evaluate exact values of trigonometric functions. So determining the exact values. Now this is everything that you've done last year. The only difference is we're doing it in radians instead of degrees. Okay? So if I'm going through it a little too quickly and you want me to slow down, please tell me that. Okay? But I'm going to assume that we know what SOHCAHTOA is. So SOHCAHTOA is that acronym to help us remember that the sine is the opposite side over the hypotenuse, the cosine is the adjacent over the hypotenuse, and the tangent is the opposite over the adjacent. Also with this, you need to know which reciprocal ratio goes with which. So the cosecant goes with the sine, the secant goes with the cosine, and the cotangent goes with the tangent. The next thing that you should remember from grade 11 are your special triangles. The only difference is, if you recall, the special triangles are 30 degrees, 45 degrees, and 60 degrees. Now we're doing it in radians. Okay, so 30 degrees is the equivalent of pi over 6 radians. 45 degrees is the equivalent of pi over 4 radians. And 60 degrees is the equivalent of pi over 3 radians. So the two special triangles that you need to know, okay? The first one comes from an isosceles right angle triangle. An isosceles right angle triangle, both sides are the same, so we call them one unit. Then you can use the Pythagorean theorem if you forget that the hypotenuse would work out to be the square root of 2 units. This is an isosceles triangle. These triangles are the same, and they have to add up to pi over 2 radians, so that makes that pi over 4 radians. So we use that triangle to help us find out the exact value of any of the trigonometric ratios pi over 4. Bless you. The other two come from half of an equilateral triangle. So if I label the side of the equilateral triangle 2, then half of it would be 1, use the Pythagorean theorem, and that would give me root 3. The angles in a equilateral triangle are 60 degrees, or pi over 3 radians, so this would be pi over 3, and then half of it would be pi over 6. So these special triangles are very important. Right? As soon as you get your test, the first thing you should do is draw these special triangles on. Okay? Because everything is going to relate to these special triangles. Okay. So just a couple of quick examples of determining the exact values. Determine the exact values. So whenever you're asked to determine the exact values, you shouldn't need to use your calculator. Okay? Although you'll have your calculator in order there to check to see whether you've done it correctly. So the exact value of pi over 6. So to figure out the exact value of pi over 6, you simply just locate where pi over 6 is. Here it is up here. And then using SOHCAHTOA, the sine is the opposite side, which is 1 over the hypotenuse, which is 1/2. So the exact value of the sine of pi over 6 is 1/2. Right? You have a calculator, make sure it's in radians. Hit sine pi over 6, make sure you get 1/2 as an answer. If you didn't, then you've messed up, and then correct it. The cotangent of pi over 4. So here's pi over 4. The cotangent is the reciprocal of the tangent. So it's the adjacent side, which is 1, over the opposite side, which is 1. So 1 over 1 is 1. So determining the exact values for trig ratios with using these three special angles is just a matter of knowing SOHCAHTOA and reading off these triangles. Any questions with that? Okay. It becomes a little bit harder when these angles that we're trying to figure out the exact value for are greater than pi over 2 radians, or greater than 90 degrees. So when they're greater than 90 degrees, we need to use something called the related acute angle. So I'm going to draw axes. Okay. When I draw the axes, I divide it up into 4 quadrants. This one here is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So are we starting on the positive x-axis? So that's where I start to measure off angles. So when you're measuring an angle in standard position, you put your terminal arm on the positive x-axis and you go counterclockwise. So if I do that, so if I take my arm and move it up to here, I've created this angle here, which I'm going to call theta, and that angle is set to be in standard position. So as I rotate my terminal arm through the axes, that's pi over 2 radians. This would be pi radians. This here would be 3 pi over 2 radians, and then back up to 2 pi radians, and I can keep going around. Okay? So we can answer any exact values if the terminal arm is in the first quadrant. Because if it's in the first quadrant, those are angles that are less than 90 degrees, and we just read them off of our special triangles. If they're in the second, third, or fourth quadrant, so if I take an angle in standard position, say it's here in quadrant 2, then this angle here, the green one, is my angle in standard position, okay? But it's going to be greater than 90 degrees and greater than pi over 2 radians, so it's no longer in my special triangles. So I have to use the related acute angle. The related acute angle is the angle between the terminal arm and the x-axis. So this angle right there is the related acute angle. So how does that related acute angle help? Well, let's look at an example. So in this part, if you wouldn't mind, those people that have a calculator, if you could take it out to help me, just make sure your calculator is in radians. Okay. So I want to evaluate, and we're just going to use our calculator for this, the sine of 7 pi over 8. Okay. So what is the approximate value of the sine of 7 pi over 8? Tell me 3 decimal places. Anybody who's willing to do that for me? Rebecca? Perfect. Okay. So the sine of 7 pi over 8 is 0.383. Okay, so I want to figure out the sine of the related angle. So let's figure out, first of all, what the related angle is for 7 pi over 8. So 7 pi over 8 is almost 8 over 8, so it's almost a whole pi. It's not quite. So my terminal arm would be here, and this angle is 7 pi over 8. I want to find the related angle. So the related angle is the angle between the terminal arm and the x-axis, the acute angle. Okay? What would the size of that angle be, the red angle? Third? Pi, right, perfect. Okay. What's going on here? Okay, so Jordan got that because 7 pi over 8 plus pi over 8 would give you pi, and that would give you on this terminal right back up to here. Perfect. So that's pi over 8. So the related angle is the red one, and the angle of standard position is the blue one. Now, how are those two angles related? If I figure out the sine of pi over 8, what's that answer in the calculator? Yeah, okay. Yeah, it's exactly the same. And that's always going to be the case. Okay? The sine, cosine, cotangent, tangent, cosecant, secant of an angle and its related angle, the related acute angle, is always going to give you the exact same answer. The only difference is, and it can be seen in here, let's figure out the cosine of 7 pi over 8 and the cosine of pi over 8. So these should give me the exact same answers, but what's the difference when I use the cosine? So first of all, what is the cosine of 7 pi over 8? Negative 0.924. And the cosine of pi over 8? Positive. So the only difference is whether the answer is going to be positive or whether the answer is going to be negative. Okay? So that leads to the CAST rule. Okay? And again, the CAST rule is something you would have learned last year. The CAST rule tells me which ratios are positive and in which quadrant. So starting down in quadrant 4, spell the word cast. Going counterclockwise. So this tells me that if I put in my angles here, 0, pi over 2, pi, 3 pi over 2, and 2 pi. So angles that fall between 3 pi over 2 and 2 pi, the cosine ratio is going to be positive, and also its reciprocal, the secant. All of them are positive between 0 and pi over 2, only the sine in the second quadrant and the tangent in the third quadrant. Okay, so now that we know about related angles in the CAST rule, now we can figure out the exact values when we have angles that are in quadrant 2, 3, or 4. So determine the exact value. This is very, 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 very important that you can do this. If I'm going too fast, if you're unsure about something, please ask. Okay? So say I want to figure out the exact value of the sine of 3 pi over 4. And again, you don't have a calculator, right? So you want to figure out the exact value. You need 4 things to figure out the exact value. You need CAST rule. You need your knowledge of related angles. I hope that's not going to be confusing because I don't want that to be a thing. Put that in there. And then you need your SOHCAHTOA and your special roundings. I'll just put it back there. Hopefully people know it's not part of the quadrant. Okay. So the first thing you need to identify is to figure out what quadrant this angle is in. Okay? So it helps to draw yourself a little diagram. 0, pi over 2, pi, 3 pi over 2, and 2 pi, quadrant 1, 2, 3, and 4. What quadrant is the angle 3 pi over 4 in? Sure? How do you know that? Okay. So, perfect. And some people still struggle with finding where the quadrants and what angle it is, especially if it's in radians. An easy way to do it, if you're unsure, is just change everything to decimals. So think of this as 0. Think of this as 0.5 pi. This is 1 pi. This would be 1.5 pi, and this would be 2 pi. And if you just take 3 divided by 4 on your calculator, you'll get 0.75 pi, and that falls between 1 and 0.5. Okay? Any questions on that? Okay. So the angle in standard position is 3 pi over 4. I want to figure out that related angle. What's the size of that angle? Ready? All right. The related angle will always, and this will save you some time, will always be pi over what the denominator is. Always. Okay? So the sine of 3 pi over 4 is the exact same answer as the sine of pi over 4. The only thing you need to do now is use your cast rule to figure out if your answer is supposed to be positive or negative. So up here in the second quadrant, sine's positive, so I keep it positive. Then I go to my special triangles. Here's pi over 4. The sine is the opposite side over the hypotenuse. The answer to this question is 1 over root. Again, you're asked to do it without a calculator, right? But you're going to have a calculator, so just check it. Get the sine of 3 pi over 4 in your calculator. Make sure you get this as an answer. Okay? So you'd have to change this into a decimal and see what the approximate answer is. Okay, so let's try this one. So it is essential that you're able to answer questions like this. The cosine of 7 pi over 6. So in order to answer it, you need to figure out what quadrant that angle's in, then figure out the related angle, then use the cast rule, and then use your special triangles. Those 4 things are the most important thing in this guide. What quadrant is 7 pi over 6? Kyle? Third. Awesome. So this angle here is my angle in standard position. I need to figure out the related angle. The related angle is the one between the terminal arm and the x-axis. How big is that going to be? Not negative. It's an angle is just we don't care about the distance, like the direction. I just want to know the distance of this guy. Right, exactly. It's always going to be pi over whatever the denominator is for the other guy. Always. Okay. So the cosine of 7 pi over 6 is the exact same thing as the cosine of pi over 6. Positive or negative? Sure? Negative. Negative because the only thing that's positive down there is the tangent and the cotangent ratios. Okay, so we've used the related angles, right? We've used the cast rule. Now we're going to use our special triangles to figure out what the cosine of pi over 6 is. Here's pi over 6. The cosine is the adjacent side over the hypotenuse. So it's negative root 3 over 2. Again, just takes a minute, not even, to check to see you've got it correct. Cosine pi over 6, get that decimal answer, figure out what the square root of negative 3 over 2 is, make sure they match. If they don't, you've done something wrong. I'd like everybody who's paying attention with me to try that one. All right, update the attendance. Okay, so first thing you do is you find out where the angle is. Got it? 4. Awesome. So you draw your terminal arm. That right there is your angle in standard position, the size of the related acute angle. Right, and that's this angle right there. So the tangent of 5 pi over 3 is the exact same ratio as the tangent of pi over 3. Is it positive or negative? What's the other one that's positive down there? Right. So it's negative. So then all you have to do is go to your special triangles and figure out the tangent of pi over 3. So here's pi over 3. The tangent is the opposite side over the adjacent side. So the answer to this question is negative root 2. If you can do this, awesome. If you understand it, the 1213 guide assumes that you can do everything up until what I've done here. Okay. It's very important that you're able to figure out the exact value. Okay, because I'm going to skip over to box B. Box A, you can do it if you want. If you don't want to do it, you can skip over it, okay, because we learn all of it anyway after box B. Okay. Box B, we are going to figure out the exact values of angles that aren't in our special triangles. So example, determine the exact value. So we can determine the exact value of any trigonometric ratio if it has a 4 in the denominator, a 6, or a 3. We can always figure out the related angle, use the cast rule, and figure out the answer. Okay? So any single fraction that has a 4 underneath, a 6, or a 3. And I don't care what's on the top because I can always figure out the related angles. Okay? Determine the exact value of the cosine of 5 pi over 12. In order to figure out the exact value of cosine of pi over 12 is we can't figure out any angle that has a 12 underneath it. So I need to split this angle up into two angles that have a 4, a 6, or a 3, doesn't matter. I can add those two angles together, or I can can subtract them to come up with this angle. Then I have to use these addition formulas. These addition formulas are taught to you in Guide B. You don't have to memorize them. You'll be getting this exact same sheet on your test. And for those of you who like trig identities, Unit 14 is all of this, and you're going to have this sheet to help you do the trig identities. Okay? So what I need to do is I need to come up with two angles that add to give me 5 pi over 12. But here's the kicker. The two angles, once I find them, I have to simplify those two angles so that they end up with a 4, 6, or 3 in the bottom. Okay? So I'll do the first one for you because you'll be like, what's he talking about? If I take 2 pi, bless you, and add it to 3 pi. Everybody agrees that 2 plus 3 is 5 pi? Okay. But if you look now, this simplifies down to pi over 6, and this simplifies down to pi over 4. So I found two angles with denominators which I can figure out. So the cosine of pi over 6 plus pi over 4, these two fractions together add to give me 5 pi over 12. This is where you have to use your addition formula for cosine. There's an addition formula for sine, cosine, and tangent, and then there's a subtraction formula for each one of them too. And they're all right here. Okay, I'm going to write down the addition formula for cosine over here so you know what I'm talking about. This is what it looks like on your formula sheet. So the addition formula for cosine is the cosine of the first angle times the cosine of the second angle, subtract the sine of the first angle times the sine of the second angle. So that's the addition formula for cosine. So what we're going to do is expand this using my addition formula for cosine. So it's the cosine of the first angle times the cosine of the second angle, subtract the sine of the first angle times the sine of the second. Once you've expanded it, now it's just a matter of solving each one of these individually and coming up with the answer. Okay? So this is where you would use your special triangles, because all of these angles are angles in my special triangles. So the cosine of pi over 6 is pi over 6. The cosine is the adjacent side over the hypotenuse, which is root 3 over 2. times the cosine of pi over 4. Here's pi over 4. The cosine is the adjacent over the hypotenuse, which is 1 over root 2. Subtract the sine of pi over 6 and the sine of pi over 6. Here's pi over 6. The sine is the opposite side over the hypotenuse, which is 1/2. And then multiplied by the sine of pi over 4. Using our special triangles, it's 1 over root 2. Now it's a matter of simplifying this. Root 3 times 1 is root 3. 2 times root 2 is root 2. Subtract 1 times 1 is 1. 2 times root 2 is root 2. I already have a common denominator, so now I just combine the numerators. And that is the exact value of the cosine of 5 pi over 12. So again, if you wanted to know whether you've done it correctly or not, hit the cosine of pi over 12 in radians in your calculator, write down the decimal, and then figure out what the square root of 3 minus 1 divided by 2 root 2 is, and make sure those two answers match. Okay? In the back of the book and in your guide, they rationalize the answer. I'm going to do that. I'm going to do that in red, because everything in red, I'm not going to expect you to do on a test. You don't have to rationalize on a test. Okay? But I want to show you how to do it, just in case you want to check your answers. So remember from guide 1-2, rationalizing, I multiply the radical on the bottom, distributing out the top. Root 3 times 2 root 2 is 2 root 6, minus 1 times 2 root 2 is 2 root 2. 2 times 2 is 4. Square root of 2 times the square root of 2 is the square root of 4. Simplifying, I get 2 root 6 minus 2 root 2. Square root of 4 is 2. 2 times 4 is 8. And then each one of these terms are divisible by 2. 2 goes into 2 once. 2 goes into 2 once. Goes into 8 4 times. So the final simplified, rational answer would be that. So a lot of times in the back of the guide, you're going to see that as an answer, and you got that. Okay? Just check it using your calculator. But you don't even really need to look at the back of the guide, at the back of the textbook for any of these answers, because you have your calculator to check to see who you've done it correctly. Cosine of 5 pi over 12 should be the exact same decimal as that guy right there. Make sense? Okay, so let's try another one. All of these addition and subtraction ones, they're always going to be over the denominator 12. That's the only way it's going to work out. Okay, it's always going to be over 12. So as soon as you see 1 over 12, and this will be the first page of your test, these questions exactly, okay, you have to come up with two fractions that either add or subtract. It doesn't matter because there's formulas for each of them to 11 pi over 12. But you want to pick numbers on the top here that you're able to simplify so that your 12s turn into 4s, 3s, and 6s. That's your most important thing. Somebody give me two numbers that'll add to 11. That would also simplify. Perfect. Okay. So 8 pi plus 3 pi. So those ones work because this fraction simplifies, right? So it simplifies down to 2 pi over 3, and this one simplifies down to pi over 4. Kyle also could have given me 9 and 2, right? Because 9 over 12 would simplify, and 2 over 12 would simplify. Okay? Could he have given me 5 and 6? Yes or no? Okay? Right, because 5 wouldn't simplify. Okay? So this really is the most important thing. Now, the most common mistake people are going to make on the first page is they're going to say, okay, this angle here is bigger than pi over 2 radians, or 90 degrees, so I want to use the related angle, and they just change this to pi over 3. You cannot do that until you've expanded out. Okay, so you can't change these two angles until you've expanded it out. So you expand it out, you grab your formula sheet, you're like, I have to use the addition formula for sine because it's sine and the plus sign. So the addition formula for sine says it's the sine of the first angle times the cosine of the second angle plus the cosine, bless you, of the first angle times the sine of the second angle. So once you do the addition formulas, once you come up with the two angles, now it's just a matter of figuring out these answers individually and then just simplifying. Okay? So the sine of 2 pi over 3, this is where I need to use my related angles pastoral stuff. So I'm going to draw my angle. 2 pi over 3 is in which quadrant? Anybody? Just keep naming them. Anybody know for sure? Get it? 2. Right? Because it's 2 over 3, which isn't quite 3 over 3, right? But it's bigger than. Yeah. So this right here is my 2 pi over 3. So then, Kyle, what's my related angle? Perfect. I don't know why this isn't working. All right. So the sine of 2 pi over 3 is the exact same ratio as the sine of pi over 3. Now I have to decide whether it's positive or negative. Positive or negative? Right, because of the because of the cash flow, right? So sine is positive up here in quadrant 2. So the sine of 2 pi over 3 becomes the sine of pi over 3. This one here is already in our special triangle, so I don't have to do any of that related angle stuff. I can just read off my special triangle that the cosine of pi over 4 is 1 over root 2. This one here, and this will always be the case because you're always working with the same angles, I have to use my related angles. Okay, but we've already figured that out over there. So this becomes the cosine of pi over 3, positive or negative? Negative. So make it negative. And then the sine of pi over 4 is 1 in our special triangles, and that's 1 over root 2. So now I've just got to go back to my special triangles and evaluate the sine of pi over 3. So the sine of pi over 3, here's pi over 3. The sine is the opposite side over the hypotenuse, so root 3 over 2. And I'm multiplying that by 1 over root 2. This plus and this minus together make a minus, so I can make that into a minus. And then the cosine of pi over 3 is the adjacent side over the hypotenuse, which would be 1 times 1 over 2. So now it's just a matter of multiplying the first fractions, multiplying the second fraction, and then combining it into a single fraction. So that is the exact value of the sine of 11 pi over 12. Again, on a test, and it amazes me when people don't do this, just check to see if you've done it correctly. Put the sine of 11 pi over 12, get the decimal answer of this, and they better match. If they don't, you've done something wrong. And all of these questions, all of them are always going to have the same numbers, like root 2, root 3, 1, they're all going to be the same looking answers. Okay? Shouldn't be any different. Okay? Because all of them come from the special triangles. So root 2, 1, root 3, 2. If any other numbers show up, you've done something wrong. Okay, so the tangent ones are a little bit more complicated because they're fractions of a fraction, so I'm going to start those on Thursday. Okay. So